Hi guys, in this video I want to talk about the quadratic equation, okay, which you might remember represents a parabola like we discussed the last time. That's this shape here, kind of a U shape. The general formula for this parabola is given by this equation here, where the y value on the y-axis is given by ax squared plus bx plus c, okay? And you might also remember that the roots of this equation, the roots being these 2 points here where the parabola crosses the x-axis, that's given by this very famous formula: x equals minus b plus or minus the square root of b squared minus 4ac over 2a. Now here I've just replaced b squared minus 4ac with delta in the square root just to make this simpler, okay? You might remember that from before. The question I'm going to tackle today in this video is this. Let's say you were asked to find the line of symmetry of this parabola. Okay? In fact, let's say you were asked to find this point here at the very bottom here. That point there is called the vertex. The vertex of the parabola. Okay? And the line of symmetry falls on the x-coordinate of that vertex. So let's call the x-coordinate of the vertex xv. We want to find xv. What is the x-coordinate of the vertex? Which is the same as the x-coordinate of the line of symmetry. Okay, now I don't want the y-coordinate, we don't care about that, I just want the x-coordinate. Okay, how would you do this? Well, you can think about the symmetry involved here to help you. Okay, but before we do that, we might simplify the problem in this way. Okay, imagine if we move this parabola. Okay, we shift this parabola down or up any way we like. Okay, as long as it doesn't move to the left or the right, we just shift this parabola up or down. Okay, then the line of symmetry never changes. The line of symmetry never changes. Okay, if you move this up or down. Okay, well that might allow us to simplify the equation a little bit, because if I should say that this point here, where the parabola crosses the y-axis, that's given by c. That's what that c means in the equation. That c is the y value when the parabola crosses the y-axis. Okay. But as I said before, we can move this parabola up or down. So I can move it down in just such a way that the c hits 0. Okay? So that's actually, we'll see this in a second, that means that's the point 0, 0. Okay, so the x and the y are both equal to 0 at that point. Okay, but the important thing is, this is the general equation of our quadratic, and I can simplify it to y equals ax squared plus bx. I can make c 0, because it doesn't affect the x-coordinate of the vertex. It does affect the y-coordinate, it would push it down, but we don't care about that. Okay? Good. In this instance, I want to now find these points here, where the parabola cuts the x-axis, the roots. Okay, so I'm going to make y equal to 0, because y equals to 0 at the x-axis, and that's where these roots are. So to find them, we're going to set y equal to 0. But I've gotten rid of c, so now I can factor x out of this to give this. Okay, I just took x out. But that means that either x is equal to 0 or ax plus b is equal to 0. Okay? If you have two things multiplied and the answer is 0, then either this one is 0 or that one is 0. Okay? Now, this one, x equals to 0, we expected, because when y is 0, x is 0 at this point here. Okay, and this gives us a more, this gives us the other root. So ax is minus b, moving the b over, and x is minus b over a. Okay, so we found that this other point here is at minus b over a. Now we can use symmetry. Okay, because this parabola is symmetric, about this line of symmetry. That means that where this line of symmetry crosses the x-axis is exactly halfway between this point and this point. It's exactly halfway between the two roots. Okay, it must be, because it's a symmetric graph. Okay, and my graph isn't very good, but you get the idea. So, halfway between 0 and minus b plus 2a, well that's 0 plus minus b over a divided by 2. It's halfway between these 2 points, which is minus b over 2a. So the x coordinate of the vertex is minus b over 2a. Okay, so we did that through a simplification based on moving this upwards or downwards, and then we used symmetry to find the answer for the x coordinate. Okay, we could have done this also by looking at this formula here. Okay, let's say our x values for the roots are given by this formula. If we find the average of the two roots, so the average of the two roots, this is also exploiting symmetry. The average of the two roots will also give us the same answer. Okay, so the first root is minus b plus root delta over 2a, and the second root is minus b minus root delta over 2a. Okay, we do x1 plus x2, you get this plus this, so it's minus b, which is minus 2b, plus root delta minus root delta cancels, and then you're left with 2a on the bottom. Okay, so those 2's cancel and you get minus b over a. But this was just the two of the roots added. We have to average them, so divide by 2 implies minus b over 2a. That's the same answer. Okay, so once again, symmetry can help us in solving problems.